Our next lesson is called Writing the Equation of a Line, Day 1. So we'll start with a couple special cases. It says, although they don't fit the classic linear function model, it is important to understand how we write equations for horizontal and vertical lines. The first exercise will illustrate the idea. Never forget, though, that when we create an equation for a curve, it simply describes what all points on the curve share in common. So I'd actually like you to complete exercise 1 on your own. Shown below are a horizontal line and a vertical line. You're going to answer the questions in the boxes to see if you can come up with how you would write the equation for horizontal and vertical lines. So at this time, please pause the video, try these problems, and then resume the video when you're ready to go over the answers. Okay, so now that you've tried on your own, we'll look at the horizontal line first. There were 2 coordinates plotted here, so we had to write down the 2 coordinate points. So the coordinates were -2, 4 and 3, 4. The next question, what do they share in common? The y value. So that tells me that this equation is y equals 4. No matter where you are on this horizontal line, your y value is a 4. You can also organize your coordinates in a table that you see I drew there. So if you're ever trying to figure out the equation for one of these, you want to plot a bunch of points, write them down. Whatever side has the same number over and over and over again, that's going to give you your equation. Horizontal lines are always y equals. You can also memorize that because those lines cross the y-axis at that number. And you can see this line is crossing the y-axis at 4. The one on the right is a vertical line. We had the coordinates 2, 4 and 2, -1. They have the x value in common. That means the equation of this line is x equals 2. And again, you can see I organized it in table form. All x equals lines are vertical. They cross the x-axis at that value. So you can see this is x equals 2 because it's crossing the x-axis at 2. So equations of horizontal lines and vertical lines are so simple that students will often forget them and get confused, and that is the truth. It's very easy to go backwards. So that's why this strategy of using coordinates to help you will be a way that you can kind of always, hopefully, remember which one is which. Okay, so horizontal lines are y equals a constant. Remember, constant's just a number. Vertical lines are x equals a constant. Again, just a number. And it says the constants can be determined by using any point the line passes through. So now I want to talk about all the other lines that are slanted in some way. They're not vertical, they're not horizontal. So this should be a review of some skills that you've learned prior. We're going to kind of summarize all the situations here. We want to be able to write the equation of a line. So to do that, we need to write it in slope-intercept form, y equals mx plus b, which means we always have to find the y-intercept and we always have to find the slope. Those are the 2 things, no matter what, we have to find. So 1, y-intercept, 2, slope. How we do that is going to depend on whatever we're given. So we're going to kind of go through all the scenarios and talk about how to find those 2 things no matter what, and see the different strategies that we have. So we are going to be given different things. And you can see here I have a slope, a y-intercept, and then finally writing the equation. So what we're given in this first example, and we're going to kind of go down in a column, is a graph with all points clearly identified. So for the slope, we should be able to pick 2 points and find out the rise over the run whenever we have a graph. So I'll pick this point here and this point here. I see that I'm going up 3 into the right 2. So up 3, right 2. And then we just have to think about whether that means positive or negatives. So if I'm going up, that's a positive 3. If I'm going right, that's a positive 2. So I've already identified one of the things that I need. If it's a graph with all points clearly identified, the y-intercept will go quickly as well. When you go to find the y-intercept, all I have to do is look and see where it crosses the y-axis. It is a very clearly identified point right there. So that is 0, 2. So my y-intercept is 0, 2, which translates to having a b value of 2. So this is our best case scenario because now all I have to do is write my equation by putting the slope in m spot and putting the y-intercept in b spot. So it'll be y equals, the slope was 3/2, so that goes in front of x. The y-intercept was 0, 2, so the 2 goes at the end. And I'm done. That's best case scenario. The next situation that we find ourselves in is a graph where I can find 2 points to find the slope, but when I go to find the y-intercept, we have an issue. So let's start with the slope. We can pick any 2 points we want to find the slope. So I'm going to pick this one and this one. I'm going down 1 and to the right 3. So down 1, right 3. Down 1 would be a -1. Right 3 would be a +3. So my slope is -1/3. That part is done. However, when I go to find the y-intercept, I cannot tell where that's crossing. So let's write that. Can't tell. So we have to use an algebraic strategy then to find the y-intercept when we can't clearly identify it. So the strategy for this is you are going to use y equals mx plus b, and you're going to plug in the slope that you should have already found and pick 1 point from the line to use as your x and y. So I'm going to go up and I will pick the coordinates 5, 3. And then I already know that my slope is -1/3. So I will use my coordinate as an x and a y, and I already have my m. So I will write y equals mx plus b, and then I'm going to plug in everything I know. My y value is a 3. Remember, because we picked this point up here, 5, 3, that was on the line. So 3 for y, that's going to be equal to a slope of -1/3 times my x value, which is 5, and then plus b. So then I just solve the equation for b. 3 equals -5/3 plus b. I have to add 5/3 to both sides. And so b is equal to 5/3 is really 1 2/3. So 3 plus 1 2/3 would be 4 2/3. So now I have both the values that I need to write my final equation. So that would be y equals -1/3 for my slope, so that goes in front of x, and then plus 4 2/3 with my y-intercept. So if I go back up and look, I see that it crossed at 1, 2, 3, 4, somewhere between 4 and 5. It kind of does look like 4 2/3, but there's no way that I could identify that just by guessing. So we want to make sure we algebraically calculate that. So that's what to do with a graph where things are clearly identified and a graph where you can use 2 points to find the slope, but you can't find the y-intercept. Our last 2 scenarios here are going to be no graph at all, and we're going to talk about 2 points versus the slope in a point. So let's go over 2 points. I still have to find the same 2 things I've always had to find, the slope and the y-intercept. So if I'm given 2 coordinates, you're going to use the slope formula to find the slope. So the formula is already written there for us. We're going to go up and label our points. In our coordinate, we have x first and y second, always. And then to denote that we have 2 different coordinates, we're going to use little subscripts of 1 in the first coordinate and little subscripts of 2 in the second. My next suggestion would be that when you write the formula, you make your outline first so that you don't drop those negatives, and then you plug your values in. So y2 is -4, y1 is 11, x2 is 4, and x1 is -1. So we have our little double negative situation here. So we're going to change those to plus signs. And now I see -4 take away 11 would be -15. 4 plus 1 would be 5, which means -15 divided by 5 is -3. My slope is -3. So now for the y-intercept, we'll do the same thing we had to do before when we couldn't identify it on the graph. I don't have a graph, so I can't look at that to get the answer. So I must find out algebraically. So we will pick one of our points. I'm going to use 4 and -4. That will give me an x and a y. And I already know from defining above, my slope is -3. So I'll write down y equals mx plus b, and I will fill in everything that I know. Y is -4. The slope is -3, x is 4, and I'm finding b. Because remember, a point is a solution, so we know it works. We already find the slope. We can now find the missing piece. So -4 equals -12 plus b. To get b alone, I'd have to add 12 to both sides. So b is equal to 8. And now I have everything I need. I can put my slope in front of x, so that's y equals -3x, and then plus 8 for my y-intercept. The last scenario you may run into is the slope and a point. So they gave us the point 8, 3. We know that's a solution. That's an x and a y. And they already told us the slope is 4. So when it comes to finding the slope, it's already determined. Next, we still have to find the y-intercept. So we have our point 8, 3. That's giving us our x and our y. And then we already know that our slope is 4. So we can take our equation, y equals mx plus b, and we can plug in what we know. Y is 3. The slope is 4. The x is 8. And we're going to find b. So this is 3 equals 32 plus b. I need to subtract 32 from both sides to find out what the b value is. 3 take away 32 is going to be -29. So my equation is y equals, the slope was 4, so that goes in front of x, and the y-intercept goes at the end. So, lastly, we determined that the equation for the graph below, this is one of the ones we already did prior, was y equals 3/2 x plus 2. So that was the equation that we got for this line here on the graph. How do you determine if your equation is correct? So I'd like you to take a second. If you want to pause the video, you can. I want you to think about this on your own and write down your ideas. And then when you're done, you can resume the video to go over your options. So now that you had time to think about that yourself, here are some options for you. How do you determine if your equation is correct? So the first thing you can do is grab your graphing calculator, go to the y equals, and type the equation in and see if you're getting a graph that looks similar to this. You can even look at the table of values. The second option is to check a point. Points on the line are solutions. So if you wrote the right equation, then any point you pick off of that line, when you plug it into the equation you wrote, it should check. So I did an example here for you. I picked the coordinate 2, 5, x is 2, y is 5. I plugged it into the equation and it checked. So that tells me we wrote an equation that properly identifies this. And you can do this with multiple points. So that concludes your lesson on writing the equation of a line, day 1.